One of the trickiest things about installing crown molding is cutting the correct angles at the corners. Each corner requires two angles: a miter angle, which is cut across the face of the molding, and a bevel angle that's formed across the end or edge. When working with crown molding, both of these angles have to be made at the same time, and that's why they're called compound angles. Accuracy is critical. An error of even 1 degree or less can result in an ill-fitting joint. The tool to make this cut is the power miter saw. The secret to making tight-fitting miter joints is coming up with the correct settings for the miter saw. One method for getting these settings is to first determine the spring angle, the angle between the crown molding and the wall. This can be done by setting the bottom edge of the molding on a flat surface and transferring the angle to a bevel gauge. Then laying the bevel gauge on a protractor and reading the angle. Since most crown molding spring angles are either 38 degrees or 45 degrees, another option is to cut a couple of test blocks and see which one matches the molding angle. With the spring angle set, the next step is to determine the wall angle by first placing a bevel gauge into the corner, then laying the bevel gauge on a protractor, reading the angle, subtracting that reading from 180, and then dividing the result by 2 to get the miter cut. The next step is to locate the miter cut on a compound cut conversion table, in our case 46 degrees. Then find the columns with the correct spring angle, ours is 38 degrees, read the miter angle, and set the saw to match. Next, we consult the conversion table to find the appropriate bevel angle and set the saw bevel accordingly. With the introduction of this digital miter gauge from Starrett Tools, this process is greatly simplified. To begin with, the spring angle can be read directly from the crown molding. The spring angle is then entered into the gauge's onboard microprocessor. Next, the wall angle is read. With a simple push of a button, the miter angle is calculated. Then the saw is set to match. With another button push, the bevel angle is displayed, and the saw is set to the identical reading. The saw is now properly set up for this particular corner. When cutting crown molding, the orientation of the workpiece to the saw is critical. In this example, I've labeled the left and right-hand pieces as well as the bottom edges. When cutting the left-hand section of an inside corner like this, swing the saw arm to the right and place the workpiece to the left of the blade, with the bottom edge away from the saw fence. To cut the right-hand section, swing the saw to the left, place the workpiece to the left of the blade, with the bottom against the fence. Here's how to handle an outside corner. Use the digital protractor to measure the wall angle and calculate the miter and bevel angles. Once again, I've marked the molding for orientation. When cutting the left-hand section of an outside corner, swing the saw arm left and place the work to the right side of the blade, with the bottom edge against the fence. For the right-hand piece, swing the arm to the right and set the work to the right side of the blade, but position the bottom edge away from the fence. No question about it, crown molding properly installed is a beautiful thing.